Alright, so in this video I'm going to be explaining another important paper with the title Gradient Gating for Deep Multi-Rate Learning on Graphs. This I cleared paper in 2023. So we present gradient gating, a novel framework for improving the performance of graph neural networks. Our framework is based on gauging the output of the GNN layers with a mechanism for multi-rate flow of message passing information across nodes of underlying graph. Local gradients are harnessed to further modulate message passing updates. So a typical residual message passing updates the node features by performing several iterations of this form. And one can interpret this as a discrete dynamical system in which f plays the role of coupling function, determining the interaction between nodes in the graph. So we consider local one neighborhood coupling operating on multiset of one neighbors. Examples of such functions used in graph machine learning, for example, Professor Bronstein in Oxford University has written that for graph convolutions. Also GCN, graph convolution, graph attention, graph GAT, all of these are examples. So we observed that at each hidden layer, every node, every feature channel gets updated with exactly the same rate. However, it is reasonable to expect that in realistic graph learning tasks, one can encounter multiple rates for the flow of information on the graph. So we propose a multi-rate generalization. So rather than just fixing this tau prior to training, we aim to learn the different update rates based on the node data X and the local structure of the graph. Now this f hat of theta is another learnable one neighborhood coupling function. Sigma hat here is a sigmoidal logistic activation function because it constrains the rates to lie within 0 and 1. So we use graph gradients to obtain the proposed gradient gating framework like this. This gradient gating. And it has some properties. So for example, the features are bounded between this lower bound and upper bound. And they talk about how it can avoid oversmoothing. Oversmoothing, which is a very challenging problem in graph neural networks. Oversmoothing and oversquashing. So this is the results on large-scale datasets. Datasets such as archive year, snap patterns.